Hello guys, what's up? Welcome back. My name is Emmanuel, and in today's video we'll be talking about DevOps. We're going to talk about what is DevOps, why is DevOps important, why is it that companies are making the big move to DevOps, right? Why is it that when you go find someone talking about DevOps or you find someone doing DevOps, right? What's so important about DevOps, right? So this video is for someone who is trying to get into the world of DevOps, but they don't have an understanding of what's DevOps. This video is also for someone out there who's already building software and maybe wants to start implementing DevOps, but don't have understanding of why they should implement DevOps and an understanding of all the benefits they're going to get if they implement DevOps. So before we even talk about DevOps, it's extremely important for us to understand something called the software development life cycle, right? We have to understand how developers build, package, and deliver software, right? How do developers build, how do they package, and how do they deliver software, right? I know we use softwares every day, we use applications every day, but how did these developers build, how were these developers able to package, and above all, how come they were able to deliver that software to us? So before we even go and we understand DevOps, we first of all have to understand these things. We have to understand what developers do in order to get a software, to us. So if we want to understand this, we have to understand something called SDLC, right? So what is SDLC? SDLC stands for Software Development Life Cycle. That's what it means. So this S here means software, this D means development, and this L means life, and this C means cycle. So it stands for the Software Development Life Cycle. So what is it? What's the Software Development Life Cycle? So basically, the Software Development Life Cycle is a process. It's a process that's used by developers, right? That's used by, software developers and project managers to design, develop, test, and deploy software. So it's a process. So if you don't want to refer to it as a process, you can also put it this way, right? You can also refer to it as a technique. You can also refer to it as a technique. You can also refer to it as a guideline, right? That developers use to, design, develop, test, and deploy software. Now, why is it that they must use this, process? Why must they use this process? The reason why they're using this process is because, one, they want to ensure that they can deliver or they can produce high quality software, right? That's what they want. They want to make sure that they can produce high quality software according to specific requirements. And above all, they also want to make sure that they can deliver that software within a budget and within a specific time frame, right? So let me summarize this. So the software development life cycle is simply a process or a technique or a set of guidelines used by software developers and project managers to design, develop, test, and deploy software. So now that you have an understanding of the software development life cycle, the next thing I want you to know is that there are some stages that are involved in the software development life cycle, and these stages are what will permit you to have a better understanding of how this process looks like. So you can refer to this as, these stages. You can also call them processes that the developers and the project manager must go through, or you can just refer to them as stages. So if you really want to understand the software development life cycle, you must also understand each stage that's involved in the software development life cycle. So the first stage is the planning stage, right? So whenever developers, they want to build a new software, let's say for example, it's an e-commerce application, right? Let's say it's an e-commerce app, right? So whenever developers want to build something like an e-commerce application, so the first thing they're going to do is they're going to go into the planning and requirement gathering phase, right? And during this planning and requirement gathering phase, developers, stakeholders, and project managers will identify the requirements and the scope of the software project, right? Now, when we're talking of developers, we're talking of, the guys who are skilled in writing code. DevOps engineers are not developers. DevOps engineers are not, I'm repeating myself, DevOps engineers are not developers. So developers are the ones who will write the code, right? And there can be different types of, developers. We can, we're looking at maybe full stack developers. We're looking at maybe backend, developers. We're looking at front end, developers, and in some rare cases we're looking at niche developers, right? A niche developer, probably someone who has like 20 years experience in a specific programming language and he's needed during that project, right? So these developers will come and, as I said, they can be full stack, they can be back end, they can be front end, they can be niche developers, and they will come down and sit with stakeholders, right? And the stakeholder, I usually refer to the stakeholder here as the person who owns the project. So in this case, he would be the person who owns this e-commerce, app, right? The stakeholders can also be, people in the company, like let's say upper management, right? Upper management has decided that they want to build an internal application to be used by their employees, right? They can be the stakeholders. Now, the stakeholders can also be a client, right? If it's a boutique consulting firm, a client can come to them and say, hey, I want to build a software. In this case, the stakeholder is going to be the client, and he would also be involved in the planning and requirement gathering phase. Then another group of people here are project managers. Now, it's important to have project managers, Why? Because they are the ones who initiate the project, they are the ones who control the project, and they are the ones who ensure that at the end of the day, this e-commerce app is delivered to the client. So these guys would all come together and they will gather requirements. They will have conversations and they will gather requirements. Like, for example, what type of application are we building? Are we building a client-facing application, an application that will be used by you and I, in this case, something like eBay or Amazon? Or are we building an enterprise level application? That's an application that we're going to sell to other businesses. Something like, for example, Shopify, for example, is an enterprise application because they sell their services to other businesses. So they'll gather requirements like that, right? They're also going to gather requirements like, what type of technology are we going to use, right? What type of technology are we going to use for our front end? What type of technology are we going to use for our back end? Now, if you're brand new to IT, all these terminologies, front end, back end, it's so confusing, but do not get confused, because as you progress in your journey to understanding DevOps, all of this, will be A, B, C. So they're going to gather all those requirements. They're going to gather what is our market size, right? How many users do we think we're going to, get on this application, right? Are we going to host this application on-prem, or are we going to host this application in the cloud, right? They're going to gather all those requirements, right? And developers and the project managers will ask a lot of questions to the stakeholders to gather more requirements that would make their life easier. Now, the reason, once they gather these requirements, they're going to use these requirements to also determine the resources that they will need, right? Like, for example, how many developers are they going to need for the front end? How many developers are they going to need for the back end? Is it a project that just one full stack developer can handle? So they're going to gather all these requirements, and during the gathering process, they're also going to make sure that they clearly specify how long this is going to take. So in this case, we're looking at time, right? How long this is going to take, right? Because we don't want to put clients in a scenario whereby they're going to spend, 5 years building that application, right? We don't want that. So they're going to determine how long it's going to take. Is it going to take 1 month? Is it going to take 2? Is it going to take 3? Is it going to take 6 months? Is it going to take 9 months, right? So that has to be clearly, defined during the planning and requirement gathering phase. Now, then the next thing also is that they're going to determine budget at this level. How much is it going to cost us to build the application, right? Is it going to cost us 10K versus is it going to cost us, $1 million, right? And you also have to understand that the resources, right, is directly proportional to the budget, right? If they're going to invest in 10 developers, the budget will be different compared to if they invest in 100 developers. So this stage of the software development lifecycle is very, very, very important, and it cannot be ignored. Then once they've gathered all these requirements and they are satisfied, right, they will then move to the next stage of the software development, life cycle. And in this next stage, we do some design work, right? So this is the systems design stage, right? Once the requirements are gathered, a blueprint is developed for the systems architecture, right? So they will pass these requirements over to designers, and designers will use this requirement to actually design the application, right? They will design the application, they will design the systems architecture, and they'll design how everything is going to look like. It's also extremely important to understand that during the design phase, developers are also involved because they're going to be the one building that thing, right? So, they're going to work with these designers to make sure that something doable is designed, right? So in this design phase, they're going to design different things. As I said, they're going to design the systems architecture. For example, if this thing is going to run in the cloud, right, it needs an entire cloud infrastructure, right? They're going to design that. And it's also important to understand that during this design phase, these guys who are designing this thing, at the back of their mind, they also have budget, right? They're also thinking of the budget. They're also thinking of how much it's going to cost to build this thing that I'm designing. So they are designing based on the requirements they give to them, right? Because they wouldn't design a $1 million system if the budget for the project is $500,000, right? It would obviously be rejected when it goes back to the stakeholders. Now, once this design is complete, it goes back to the stakeholders for approval, right? So it would go back to them. They will look at it. They will look at the UI, UX, system architecture, the database designs. They'll look at some data flow diagrams and all those good stuff, and they will either approve or reject it. But once it's approved, it will then the project would move to the third stage of the software development lifecycle, which is the implementation stage. And this is where developers will start, writing the code, right, for this application. And they may likely write the code in any language of their choice, or most importantly, in the language that was, recommended in the first stage, which was the planning stage. And this can be this can be PHP, this can be something like Python, this can be something like .NET, right? It can be Node.js, it can be React, right? It can be Go, it can be any programming language of your choice, or the programming language that was chosen during the planning and requirement gathering phase. So these guys will start writing the code. They'll start writing it, and they'll start doing a lot of things, and it's going to take them some time to actually write this code. Then once they're done writing the code, it will then go into the testing phase, right? It will then the project will move into the testing phase. After the software has been coded, it goes through rigorous testing to identify and rectify any bugs or issues. Now, this phase is very, very important. This phase is extremely important. Why? Because we don't want to put ourselves, or the company does not want to put themselves, or the developers themselves, in a situation whereby they're going to spend 6 months building this e-commerce app. Then once they give the e-commerce app to the customer, then the customer will come back and say, hey, my customer is trying to use the app, but it looks like the payment service is not working, right? So they would go through testing to identify things like this. So they'll make sure that, if a customer can add product to cart, can they check out? If they can check out, can they make payments? And if the payment feature is not working, they will do what? They will rectify that issue. So there's a lot of testing that's going on in this phase. And some companies may even bring external people, or maybe few users. They may bring maybe 10 users, and they will ask these 10 users, to test the application and give them some feedbacks. Then once they've tested the application and everything is fine, that's when it moves to the next stage of the software development lifecycle, which is the deployment phase, right? Here is where the application is deployed to the target environment, making it accessible to users. By users, they mean you and I, right? It means you and I, we can now use that application. It means we can now go to that e-commerce website. We can go through their product catalog. We can add products to cart. We can check out. We can put our shipping details. We can make payments, sit and receive the product. So here is where the end user will start using the product. Now, another thing I also want you to understand here is this word called target environment. Now, during this implementation phase, what will developers do? Developers will set up environments, right? Developers will set up environments. Environments in this case refers to where the application will be hosted. It refers to things like servers, storage, databases, networking. So they will set up environments, and they will set up different types of environments. The first one they will set up is a dev environment. That means a developer environment where they'll use it to do their testing. They will set up a staging environment. Now, the staging environment here, it's also known as the pre-prod environment, and they will then set up a prod environment. That's a production environment where the live application actually runs. Some companies go as far as setting up a QA and a UA environment, right? Technically, you don't really need all these environments. It just depends on you and your application and all the requirements around your application. So once they are doing some implementation, they will do the implementation where on the dev environment. Then where will they do the testing? On the staging environment. So this testing is actually taking place in the staging environment. Then where will they do the deployment? In the prod environment. So when it gets to prod, when they deploy to the prod environment, that's where you and I can use it. So any application you're using right now is actually running in a production environment. Now, if you subscribe to this YouTube channel, I promise you that I'm going to teach you how to set up different environments, how to set up dev, staging, prod environments, right? Don't forget to hit that subscribe button. So now these are the stages, right? There's planning, there's system, there's implementation, there's testing, and there's deployment. Now there's another stage that is very, very important, and that stage is called the maintenance stage, right? The maintenance stage. Once these developers create this application, test this application, and deploy this application needs to be maintained, right? And if you don't want to call it the maintenance environment, you can call it the post-deployment environment. That's still fine. So what do they do? What do they do during this stage? What they do during this stage is that they regularly update the application, right? And they also modify the application based on user feedbacks. So what do we mean by this? It means the user will start using this e-commerce application, and as they are using this e-commerce application, they're going to give their feedbacks, right? They're going to say things like, oh, I tried to check out and it didn't work, or your system is too slow, or stuff like that. And the client or the stakeholders or the developers will receive these feedbacks, and based on these feedbacks they will modify the application. They will make changes on the application. And the reason why they're doing this is because they want to do what? They want to stay, they want to remain relevant. Now once that stage is complete, by the way, that is not a stage that gets completed. The maintenance stage of the software development lifecycle is something that will always continue. It doesn't end. Then there's a bonus phase or stage of the software development lifecycle called the closure, right? Called a closure. At this point, the software may either be replaced with a newer system or retired altogether, which means the client may be back in 5 years and say, hey, remember that e-commerce application we built? I don't want it no more. I want something brand new, right? Or the client may come back and say, okay, this system we built was running on-prem. I want to move it to the cloud. I want to completely retire my old system and I want to move my application to the cloud. The client may come back and say, hey, they want to move from one cloud provider to another. Maybe they started with Azure, but now they want to move it to AWS. All of this fall under the closure phase. Now it's extremely important for you to understand that when I'm in closure, I don't mean like deleting the application. No, there are some things that may happen. The client may choose to implement a completely new technology for the backend. Maybe the backend was .NET and the client wants to move to Node.js, right? A complete reset of everything happens in this stage, and we've seen it with a lot of companies. So that is the software development life cycle, and those are the stages that are involved in the software development life cycle. So it's important for you to understand what the software development life cycle is. It's simply a structured process that's used by developers, project managers to design, develop, test, and do what? And deploy applications. And the reason why they're doing this is because the reason why they're using this is because they want to ensure that high quality applications are delivered to customers within a specific time frame and within budget. And you also have to understand that there are stages that are involved in the software development lifecycle. The first stage is the planning and requirement gathering phase, right? Now, in some videos or books or articles you're going to read, they're going to break the stages into two. They're going to have planning, then they're going to have requirements. I just decided to make it as one because I just feel like it's one. So you're going to have the planning and requirement gathering phase where they're going to gather all the requirements regarding the project. You're going to have the design phase where they're going to design, the project, come up with a proof of concept and stuff like that. You're going to have the implementation stage where the developers will start writing the code to bring that software to life. Then you're going to have the testing phase where the developers will test, make sure that there's no problem with the software. Then you're going to have the deployment stage where the developers will deploy this to a specific target environment, in this case the production environment. Then you're going to have the maintenance phase where they're constantly maintaining the application based on the feedback they're getting from consumers, and they're constantly updating the application to perform better and stay relevant. Then in some cases you're going to have closure stage, whereby the client comes or the stakeholder will come and say, hey, we built this application, but we want to retire this application completely. We want something new. We want a new backend. We want a new front end. We want a new system architecture, right? Maybe, as I said, maybe it was hosted on Azure, and they come and say, hey, we want to move from Azure and we want to get into AWS, right? Or we want to move from on-prem and want to get into AWS. So this is kind of what is involved in this stage right here. Now, you have to understand that all companies that build software use the software development lifecycle, right? Because of all the advantages it has. But not all companies use the software development lifecycle the same way. And the reason is because there are different types of software development life cycles. And these types are known as methodologies, right? So they can talk about software types of methodologies in the software development life cycle. And we're just quickly going to look at some of those methodologies, but we're going to dive deeper into 3 of the methodologies, which is the Waterfall, the Agile, and DevOps. So let's look at those methodologies. Let's start with the first one. So the first one here is the Waterfall methodology. Now I'm going to explain to you why is it that it's called the Waterfall, why the name Waterfall. I'll explain to you when we dive deeper into what the Waterfall is all about. So, but before we get there, let's have a broader view of what the Waterfall is. So the first thing you have to know is that the Waterfall is the oldest and most traditional software development lifecycle model. Is the oldest. It's actually the first model in the world of software development, right? It is a linear model in which each phase must be completed before the next phase can begin, which means that the first phase, which is the planning phase, must be completed. Then after requirement gathering must be completed. Then after, developers must, go into implementation. It must be completed. Then hosting. And so each stage must be completed before the next stage can start. Then the second one is the iterative model. This model involves repeating the phase of the software development lifecycle multiple times, with each iteration building on the previous one, right? That's kind of how this model looks like. Then you have the spiral model. This model combines the waterfall and iterative model, which each iteration includes risk assessment and planning. Then you have the fourth one, which is the agile model, and this is the model you're going to see a lot, and this is kind of what a lot of companies are using right now. And I'll be discussing why is it that companies are using this agile model a lot, right? And actually, this is the model that companies are trying to stay away from and adapt to DevOps. So this model here is extremely lightweight and flexible. So it's a flexible approach to the software development lifecycle that emphasizes on collaboration and continuous improvement. So the whole idea of this is collaboration and continuous improvement. That's what the company are looking for when they're trying to implement this model. So they want to make sure that there's collaboration among all the stakeholders that are involved in building this software, and they also want to make sure that there's continuous improvement. So whenever something comes up, they want to be able to tackle that thing and fix it before it creates a bigger issue. Then the fifth one is the DevOps model or the DevOps methodology, and this is what companies out there want to start implementing, but they are having difficulties doing so. And this is kind of the best model in the world right now. And what this model does is that, basically a culture and a practice that combines software development and IT operation. By software development, we're talking about it combines developers, plus operation, right? By operation, we're talking about those who in charge of building the infrastructure where the application runs. We're talking about people like solution architects, for example, network engineers, for example, security engineers, for example, anyone that's involved in the day-to-day maintenance of the infrastructure in which the application is running, right? So this model is actually there to do what? To combine developers and operation, and the reason why it's doing this is to shorten the software development life cycle and improve quality. So what this model is trying to do is trying to save time, it's trying to improve on collaboration, right? It's trying to save time, it's trying to improve on collaboration, and it's also trying to ensure that there is quality. So as I said earlier, we're going to take 3 of this model. One would be the waterfall model. We'll understand the waterfall model in detail. Then the second one we're going to look at is definitely the agile model, and the third one we're going to look at is the DevOps model right here, right? So let's start with the first one, which is the waterfall model.